free to pass. I will not be, whoops. If you don't know the answer, feel free to pass, but I want to give everyone a chance here to, I want to give everyone a chance here. Okay, here we go, warm up A. Now, when I talked to Mr. Netta, Mr. Netta's a great guy for helping me out like that. This says find f double prime of x. For f of x equals 5x4 minus 3x squared plus 2x plus 1. One other way that the textbook sometimes writes this is d squared y over dx squared. Those mean the same thing. Okay? I can't guarantee that I won't write it like that, but this just means second derivative. All right, Chris, would you like to start, please? We're finding the first derivative.
Yeah, for the first derivative, I found 20x cubed minus 6x plus 2.
Okay, good. And if you remember, the 1 just disappears, okay, and everything else goes. Question or answer? Okay, well, let's just hold on. I'm going to do Spidey here. That's okay. All right, Austin, okay. Austin, can you find f double prime of x for me, please?
Yeah.
Yeah. Okay. Now, remember, if there's questions where that came from, all we did was we took the first derivative, and we just took the derivative of that again. All right, so Mr. Netta said you guys have more difficulty with the first day's lesson. Might have been some of the word problems, might have been the trickier part, but this part of the lesson should have been straightforward, right? It was just one derivative to the next. Press yes.
Can you do like a third derivative of this?
You could do infinity derivatives, you could do.
Okay.
When you get to things like sine and cos and things that don't go to 0. Because this would eventually go, third derivative would be 60 or 120x, then 120, then nothing. So, let's see. Is that a question or a stretch? Question? This here? So, okay, because remember the 2 comes down to this, right? No, 6 is your that. 3 times 2, right? Okay. All right, letter B says, oh yeah, this is, we start to get the good ones. So we have f of x equal, well, it's not actually. This is a level 1 chain rule question. What do you mean? Yeah, right. You haven't seen today's lesson yet. To the 4. Okay, so just a quick review of chain rule. All the chain rule says is you're going to take the derivative of the outside. So this looks, if you sort of squint, that looks like something to the 4th, right? That's what it looks like. All chain rule tells you is when the something is messy, you take the derivative of that afterwards and put it to the side. That's all it is. All right. So Noah, since you're here, can you take the first chain rule? Can you take the chain rule of this? What do we get, please? F prime of x.
4 minus x squared minus 4x minus 2.
Okay, that was super fast. Let's talk slowly about how we got that. The 4 comes down to the 4. The power goes from 4 to 3. And then the derivative of the bracket is just 6x minus 4. So 3x squared changes to 6x and negative 4x changes to negative 4. Yes.
Does it matter what order it's in?
Yes, it does.
Because
we're
of
not.
the exponents, right?
Yeah, so what I'd probably write it like this. I'd probably actually write this as factored form. I'd probably write this as 8 3x minus 2. That's why I'd probably write it.
Oh, okay.
Because what's going to happen in the next unit is we'll be graphing this, okay? So you want this to be in factored form. So this would give you roots and things like that, okay? So it's probably good. Is that okay how I got that? I just factored 2 from 6x minus 4. Yeah. Oh, because what I did was, I skipped a step there. I just divided this by 2, right? Because 6x and 4 both divide by 2, so I took out a common factor. What's that? Why? Because you just want it to be in the smallest form. Because this is we're going to be graphing this very soon, so I just want to get you in good habits to turn the roots and all that stuff. Yeah, you totally could. You totally could. Okay, the thing is, it doesn't really. Yes, you probably should have using the same rigor. All right, letter C. I'm going to go to a whole new board for this one. And please put a star beside this one because this is the crux of today's lesson.
And a heart?
No, you can put a heart if you want to as well. So f of x equals 2x minus 3 squared 3x minus 4 to the fourth. Okay, now this is the easiest question you're going to get on your test, is this one. Okay, this is the simplest one you're going to get on your test. There's going to be nothing that's easier than this, so I want to make sure that we have an idea of how to do that. Now, what the heck is this, other than a nightmare? There.
It's two functions multiplied by each other.
Right on. And if you have two functions multiplied, what do we call that? Product rule, I hope is what you're saying.
That's what I was going
That's
to
what I
say.
say?
Yeah.
So we're going to use product rule for this one, okay? So if you remember how product rule was when I was here, it was the derivative of the first one times the second, plus the first one times the derivative of the second. Does that make sense? Okay, so f prime of x, g of x, plus g prime of x, f of x. Okay? All right, so, Cecilia, can you be brave, please, and just give me the derivative of this first part, please. What does that turn into? Okay, awesome. Unfortunately, we're not done.
Why is it not doing that?
Okay, because, just watch, this 2 came down, really, and then the derivative of this is just 2.
Oh, okay.
Right, so it's like a chain, it's like a product and a chain going together here, okay. All right. And are you ready for the second half? We do the second half, which I'm going to do in green. I think that's what you said. I hope that's what you said. All right, now this is the new part. Okay, guys, so this is where I want everyone to pay attention, so I didn't leave this good in my note. All right? We have to take out some common factors here. What's common between both terms here? Now let's just think for a sec. What's common between both terms? Just give me one thing that's common.
So there is the 2x minus 3.
Good. So both of them have a 2x minus 3. So I'm going to cross that. I'm going to cross that. Someone other than Chris, what else does both of them have in it? Yeah, wait. Well, we're factoring it. That's all we're doing. So we're dividing them both by 2x minus 3. This is like factoring by grouping, right? Like we're factoring.
Yeah.
Did both. Well, there's no equals though here, though, right? So I did one. I took one from here and I took one from here because this is 2x minus 3 squared. So I took this is really 2x minus 3 and 2x minus 3. Like basically what I'm doing is this. They both move to 2x minus 3. And then I'm just looking 4 plus 2x minus. Like that's what I'm basically doing right there. Too much?
Where did the 3 come from on here?
Oh, because the derivative of the brackets here, right? The derivative of 2x minus 3. Let's try again there, Mike. Sorry, I didn't answer that. So. Okay. So we have a 2x minus 3. What else is common? Yeah, 4. Both of them have a 4. So I'll take that out. 4 comes from there. And 4 comes from there. Good. What else do I have that's common? 3x minus 4 cubed. So that changes to a 1, and that cancels. Okay, so let's check out what's left then. It looks like inside the brackets I have a 3x minus 4 from the first term, plus 3 times 2x minus 3.
Would you just literally, like,
We gotta smush that
you gotta,
together.
yeah.
So let's just give it a second, let this sink in for a sec. Because this is an easy factoring. This is an easy factoring. This is like level 10 factoring, you can also say.
Next level 10.
Nah, level 9 factoring. Just today's lesson's level 10 factoring. So I call this equals 4 bracket 2x minus 3, 3x minus 4 cubed, and that turns to 3x minus 4 plus 6x minus 9. Okay, hold on. gonna give you guys a second to let the power of this one sink in. Okay. And then, whoops, and then let's, whoa, what happened? Uh-oh. There we go. Okay. Now, the other question is, why did I have to do that?
So it looks nicer.
Well, yes, it looks nicer. Secondly than that, I've gotten another root out of it, which is 9x minus 13. Okay, so you see what I did there? I ended up getting another root. Also, it does look a lot, it's a lot easier to manipulate algebraically.
Oh, and I'm guessing that also because, like, in the beginning it was like a plus, you kind of wanted to all multiply by each other, maybe?
Yes. Yes.
Yeah, sure. Okay.
I'll go with it. Okay, I have 2 questions to do from homework, then I'll take up today's lesson. And I'll start today's lesson, okay? So here we go, this is number 16.
May I go get a drink?
Yes. This is page 118, number 16. So this one leads in very nicely to today's lesson. All right. Now, unless you know the short form, which of course you don't know of, okay? We have to find a way to break this one down. Now, I don't like this. It's a fraction. I can't deal with that as a fraction. Matt, do you have any idea of how I can change that into something like I can maybe use product rule on? And Vince? Okay, somebody help me here. What do we do with that denominator? So you can do something with the denominator. Alistair, go ahead.
Exponent becomes negative.
Yeah, let's call it y equals, whoops, 4x minus x cubed times 3x squared plus 2 to the negative 2. So everyone see what we did there? A fraction turns to be a negative exponent. Now we can just use product rule again. Okay. Victoria, can you please take the derivative of 4x squared minus x cubed for me, please? And that turns into 3x squared plus 2 to the negative 2. All right. Okay, hopefully that first part's no big deal. All right, Derek, can you be brave, please? Take the derivative of this for me, please.
That'll be 6x.
One more time. No. Careful, this is, no. Sorry, did I say that right? I said that too many no's. I didn't mean to say too many no's. So this just comes down 1, the base stays the same.
So we're doing the outside.
Yeah, so we'll do, I'll write this part first. So 4x minus x cubed. Okay, keep going here. So this turns into a negative 2, right? You probably skipped a few steps to me, that's okay. Does that hopefully look good? All right, now here comes the fear. Are you ready for the fear? Yeah, go ahead.
Why do we do the chain rule for the side one?
Because there was no powers here, right? Technically we did without telling you about it, okay? Because that was like a power 1. So 1 to the power 0, anything to the power 0 is equal to 1, so that just crossed out, right? So then just if there was yeah. All right, now here's the tricky part, okay? And this is what I have to sort of get that we're going to do here. What's common between both of those? Yeah, go ahead.
So 3x squared plus 2 bracket negative 2.
Yes,
To the power of negative.
but I'm going to cheat on this one, and you guys don't know this yet, so you don't know. I'm going to use the negative 3. Okay, because what's going to happen otherwise, if you just use the negative 2, there's going to be a fraction on here and we can't combine it. So I'm going to factor out, hold on a second, I'm going to factor now hold on a sec, just wait. Now for what this if I'm going to factor out all that to the -3. Now the reason I want to do this, for those people that are rubbing their face here, the reason I want to do that is I want to get rid of all the fractions. That's what I'm cool. If I could take out a -2 and left the fraction here, I can't do anything with it. Okay? Now here's the tricky part though. What's this? If I take out a 3x plus 2 to the -3, what does, I'll do this up here, what does 3x squared what does that equal to? So I'm taking out a -3. So the power of positive 1. Okay? So I'm going to say dy by dx equals 3x squared plus 2 to the -3. Then I'm going to be left with 4 minus 3x squared, 3x squared plus 2, plus minus 12x times 4x minus x cubed. Now I'm going to let the power of this question sink in again here. Okay? And we're going to get more into this. We'll find a short form to do this. I guess you probably could as well. And then factor this by an x. Yeah, good idea, Bailey. So what Bailey decided, which is correct, she's going to call this correctly x times 4 minus x squared. No, that isn't the same then. Right, Bailey, you can't do that because that's 4 minus 3x squared, not 4 minus x squared. But good try though. So why'd you say that's embarrassing? That's not embarrassing at all. That's good. Good try. Now before we're done, I'm going to FOIL all this junk out. 12x squared plus 8 minus 9x4 minus 6x squared minus 48x squared plus 12x4. 12 minus 9 is 3x to the 4. 12 minus 6 is 6. Hold on a sec for those that are questioning. Hold on, give me a sec.
I'm questioning.
Just don't question yet. Now, before you guys say, wow, that's an impossible question, we're going to find an easier way to do that today. Okay, there will be an easier way to do that today, okay? Because this is difficult. When I was in high school, this is the third rule we're going to do today, which is called the quotient rule. When I was in high school, there was a student in my class, one of my best friends to this day, and he refused to use the quotient rule. So for some unknown reason, he decided to do every question like this. I shake my head still when I think, okay, I'm fighting with the teacher, that there's no point in using the quotient rule. Okay, because this is painful. All right, and we're going to show you a better way to do things today. Yes?
So if you have like a huge bracket like that where it's like that minus that or that plus that, then you just expand it
You
out.
have to simplify.
Okay.
And you would try and factor that. I don't think that factor is solved, though. I don't think 24 and 42 doesn't factor. Okay. I have one more quick example. Do this one's faster, and then we'll move on to today's lesson. I'll open that door because it feels cold in here again to me.
We just write
Yeah, if you want to write out prime of x instead of dy by dx, feel free. That's okay. Just the question said y equals, so I did dy by dx. All right.
The dx kind of looks like a laughing face with a finger.
does no.
Yes, it does. Yes, it does.
Okay. You're calculating? You're texting or calculating? Okay. All right, are we good? Sort of, within reason. Now, this is what I said. This is sort of what your test is going to look like questions like this, okay? Oh, don't roll your eyes at me, okay? This is calculus. This is not grade 9 math, okay? You can handle this. I'm going to do number 20 here quickly, and then we're going to move on here. This is number 20. Number 20 said, this one's easy. This one's easier. If y equals square root of 2x minus 1, find d squared y by dx squared. Do you want me to do this one, or are we okay after that mess? Plus 1? Okay. Okay, so the first thing I'm going to do, I'm going to write it as f of x equals what? What do I do to that square root? Luke, what do I change the square root into? 1/2. Very good. So the power 1/2.
Is d squared y over dx squared just the derivative of dy over dx?
Yeah, I wrote down the other words. It's f double prime of x is basically what it is.
Okay.
All right, Nicole, you show off your skills here, please, for chain rule. What do I do with this, please? Okay. Okay, good. What does the power turn into? Negative 1/2. Good. And then this is just going to be times by. Yeah.
If that's the case, can't we just times the 2 by the 1
Totally
over 2?
can. So I'm going to say that f prime of x is going to equal 2x plus 1 to the negative 1/2.
That's convenient.
It is very convenient. Bailey, can you show off your power rules or chain rule skills for me, please?
Is that like the,
F double prime of x equals?
oh, the negative 1/2
Yeah.
2x plus 1 over 2.
Yeah.
And
Good. So it equals negative 1 over the square root of 2x plus 1 cubed. Okay, this is a question. Can I keep going with this?
where's it?
Oh, 1/2 times 2. 1/2.
Oh, right, okay.
I could literally keep going with this forever, okay? Because all that would happen, the denominator would get bigger. All right? So if that doesn't blow your mind, nothing will today. All right? You can take the 25th derivative. Now, what's the application of 25th derivative? I don't know. Please don't ask me, okay? They will probably exist inside your cell phones, okay? We're going to be talking about the first and the second derivative in this course, all right, as far as applications. Okay, is this starting to make a little bit of sense? I didn't blow your mind too much, I hope. It's just this is just algebra. A lot of the stuff on the tough stuff, that was just algebra. That's all that was. Okay, I'm going to save the video and then we're going to move on momentarily. What time is it?